Have you ever mounted an external drive and then tried to write to it and then you get a permission denied error? Sometimes you can just do a chmod of that directory to add the right permissions and it fixes everything. But then sometimes it doesn't work. So why does it work sometimes and doesn't work other times?
Failure!
In this video, we will look at the umask utility, which will help you understand what's going on. Did you know that life and beer are very similar? You know, you have to chill for best results. If you subscribe to this philosophy, then you also need to subscribe to my channel for more free-flowing beer. On a typical Linux system, when you create a folder, the default permissions is that everybody is allowed to do everything. That is, everyone has read, write, and execute privileges. And when you create a file, the default permissions is that everybody is allowed to perform reads and writes on that file. The file is not executable by default. It's a good security practice because you don't want to allow any random file to be executed. You have to know what you're doing to create an executable file. So let me go ahead and create a file and a directory to look at the permissions. I'm going to cd into my documents folder. Then I'm going to do make dir of new dir. Then I'm going to type date and then redirect that to a file called new file. And then I'm going to look at the permissions with ls-l. But wait, didn't I just tell you by default everyone is given all permissions for the directory and everyone is given read and write permissions for a file? If that's the case, why is the group and others not allowed to write to the file or the folder? From an operational sense, that makes sense, right? Because if you're creating a file, you don't want just anyone to be able to write to it without you explicitly giving them permission. And that's where the umask comes in. The umask is a utility that changes the file permission bits by masking what the current shell environment is set to. So if there's no umask set, then the file permission should be read, write, and execute for everyone for folders and read and write for everyone for a file. So let's see what the umask is currently set to and what effects it has. To do that, I just have to type umask by itself. And we see 0022. All right, we're going to get into that shortly of what that means. So right now we're going to go ahead and change the umask to 0 so that we can see the file permissions that I was talking about as a default. All right, so I'm going to set umask 0000. And now when I create a file by doing date, redirect into new file 2, and then looking at it by ls-l, we can see that it has read and write permissions for everyone. So now let's talk about what exactly this umask is doing. If we look back at the original value that we started with, it was 0022. And this format is pretty much the same format as the change mode bits. So if you have no idea what those are, you can go ahead and check out this video up here on changing file attributes. I explained that pretty much in detail. Like I said earlier, the default behavior of Linux is to give read and write access to everyone, so the mode bits will look like this. It's going to be a dash, read, write, dash, read, write, dash, read, write, dash. Right? Because it's going to be the permissions for the owner, the group, and then others. And now when we apply the mask of 0022, that's essentially basically putting a masking value in these positions right here, right? Because that's the 2 position. And so what that means is that the resulting permissions will look like this. It's going to be read, write, dash, read, dash, dash, and read, dash, dash again, because these bits right here are masked out. Let's look at another made-up example. Let's say that for whatever reason, we only want other people to be able to read and write to any file that we create. So basically, we want the permissions to look like this, right? So for the owner, it's going to be dash, dash, dash. For the group and others, it's going to be read, write, and then dash. Right? So if this is the result of what we want, and what we're starting off with is the read, writes for everybody, then the mask is going to be a 1 and a 1 in these positions right here. Okay, so the 110 basically is a 6, right? If we convert the binary back to a decimal. So let's go ahead and set our umask to 0600. All right, and then I'm going to go ahead and create a file again by doing date, redirect into new file 3, and then do an ls-l. Now when we create a file, we can see that the owner does not have read and write permissions, but the groups and everybody else does. Now let's try to answer the question from the beginning of this video where we were trying to write a file in a mounted external drive. So what I'm going to do is go ahead and cd to that mount point, and I had already mounted that folder, so I'm just going to go ahead and cd into /mnt/usb2, and then I'm going to go ahead and create a file here by doing the same thing we did before, by doing date redirect into new file. And here we get a permission denied error. So let's explore why. Let's look at the permissions of the folder that we are in by doing ls-ld of dot. And we see that the folder is owned by root, and only root can write to it. So if we wanted to write to this folder, we can do it as root by adding sudo to the command that we typed earlier, right? So we can do sudo date redirect into new file 2. And this also errors out because if you look at this command closely, we are executing the date command as root, but the redirect is done as an ordinary user, which still does not have write permissions. So I have to be a little more creative and use the sudo along with the t command to write out the file. All right, so what I'm going to do is do date and then redirect it into sudo and then the t command and then new file 2. And then I'm going to basically do the redirect of the standard out to dev null because I don't need to see what's on the screen. Now when that's done, we can do ls-l, and we see that new file 2 is there. So let's find a better way of doing this. So another way of doing this is to change the owner of the folder, right? Because if we're going to be writing a lot of files to this, I don't want to keep on having to do sudo and these other crazy constructs. So I'm going to go ahead and take a look at the folder again by ls-ld of dot, and we can see that root is the owner. So I'm going to go ahead and change it to me by doing sudo change owner blue monkey forensics of dot. And then we can confirm that I am the owner now by doing ls-ld of dot. And it looks like I am the owner. So let's go ahead and try to write out the file again by doing date greater than new file 3. I don't get an error this time. If I do an ls-l, I can see new file 3 being there. So this is a method of writing to an external drive that was mounted by root, right? I can change the owner to me, so I can start writing to it. Great, we solved the problem. Or did we? Let's do this exercise again, but I'm going to cd into a different mounted external device. So this time I'm going to cd into /mnt/usb. And then I'm going to do the same thing again. I'm going to do date greater than new file. And I get the permission denied error just as before, right? No problem. We've already figured out how to get around this. We can use the sudo trick with the t command. So I'm going to do date, pipe it through sudo, and then t, and then into new file, and then redirect the standard out to dev null. And then I don't get an error, so let's do an ls-l. And it worked great, right? So we do have the new file there. But again, this is clunky, right? Having to do the pipes and the sudo and the t and all that. So let's go and use the other method of just changing the owner of the folder. So let's go ahead and do ls-ld of dot again to see the owner is root. And I'm going to go ahead and sudo change owner blue monkey forensics of dot. And this time we get an error that changing ownership of that current folder is not permitted. Huh, that's interesting. So what's the difference? I'm not sure. But because we can't change the ownership, maybe we can change the mode bit so that everyone can write to that folder. So I'm going to go ahead and do sudo chmod a plus w, right? So everybody, all, is going to get the write access. And I want to grant that to /mnt/usb. And the command line comes back with no errors, so that's good. Let's do an ls-ld of dot. And wait a minute, the mode bits did not change, so the command of chmod executed successfully, but it did not do what it's supposed to do. this is really bad. What's going on here? Well, if we take a closer look, this is because we are operating on a mounted external disk. Okay, so things are a little bit different than an ordinary folder. So let's take a look at what the mount command did for this particular device. So I'm going to do mount and then pipe that through grep of the word USB. And now here's the entry. Here's all the mount flags. What we see here are two flags of interest, fmask and dmask. These stand for the file mask and directory mask, and they're there to set the permissions for files and folders respectively, and are specifically for FAT file systems. Right, so that's the difference between this example here, where things are not working, and when I did it earlier, when it did work. When I did it earlier, it was basically for a ext4 file system, so everything works just fine, right? Because ext4 understands permissions and ownerships and whatnot. But FAT file systems don't have that, right? That's why we're having these issues. So by default, if you don't explicitly specify the fmask and dmask in the mount command, their values will be that of the umask of the calling process, right? And we looked at umask earlier. So let's take a look at how we fix this, right? In order to do this, let's go up one level, get out of the folder here, the mounted folder here, and then I'm gonna do sudo umount of /mnt USB, and then I'm gonna go ahead and mount it again. This time I'm going to specify some options. So I'm gonna do sudo mount -o fmask equals 0000, comma dmask equals 0000. And now I'm going to mount /dev sdb1 to /mnt/USB. Right, so this time what's going to happen is that when we mount, we're explicitly setting these masks to 0. And so now the mount point basically has read, write, and execute permissions for everybody. So if we cd back into /mnt/USB and we do the ls-ld of dot, right, we can see that we actually have all the permissions now for this folder. And now we can write to this folder without having to do a sudo or any other complicated commands, because we deliberately set the mask to 0 so nothing is blocked. And another thing we could have done, which is probably better, but I wanted to show you the mask options first. What we can do when we mount is specify the user ID and group ID of the files. Right, so what we're going to do is go ahead and cd ... to get out of the mount point. And then we're going to go ahead and do sudo umount of /mnt USB. And now let's find out the UID and GID for my account by using the ID command. Right, so we see here that my UID is 1000 and so is my GID. So let's go ahead and mount again with those specific parameters. So I'm going to do sudo mount -o UID equals 1000, comma GID equals 1000, and then /dev /sdb1 to /mnt/USB. All right, let's go ahead and do the mount command and then pipe it through grep USB again. And what we can see here is that we did specify the UID and GID commands, and then once again those fmasks and dmasks are using a default that it picked up from the regular umask, right? Because we didn't explicitly specify them. But that's okay. We actually are better off just doing it this way, because now let's cd into the mnt USB folder, and then we can do the ls-ld of dot again. And now we see that Blue Monkey Forensics actually is the owner of the folder. Right, so now because we are the owner, we don't have to muck around with the sudo commands and all the other crazy nonsense. So now we can do date redirected to new file 2, and then it doesn't complain, so ls-l shows that new file 2 was created, and it inherits all of the properties of the parent, right? So it's got the read and write permissions that the folder has. So in this video, we saw that there is something in the Linux file system called umask that controls the permissions for files and folders created. The umask could be set in several different places. The default location is either in the file named etc profile or etc login.defs, and it depends on which distro you're running. On my Cane distro, it's in etc login.defs. So I'm going to go ahead and VI, take a look at that file so you can see what's going on. So you can see here that the default umask is already set to 022. Okay, and as it says here, historically the umask for a Debian system has been 022, but it does say that you can change it to whatever you want. And they think that like 027 or even 077 is better for privacy. The 077 would mask out any permissions for a group and others, therefore only allowing the owner access to the file. Right? But again, it depends on what the sysadmin wants to do, and he can change it in this file, which will ripple through to all of the other users. And as a regular user, you can also edit the file named .profile in your home folder, and then in there you can basically set your own umask to something different. And of course, the other place you can set it is on the command line, as we demoed earlier. And we also saw that the umask value actually helps determine the fmask and dmask values that the mount command uses when it mounts a fat volume. So depending on what you want to do with the mounted volume, you may want to manually set the fmask and dmask values when you mount a fat volume. For more videos with Linux tips and tricks, make sure you watch these videos here. Click on the blue monkey to subscribe. Thanks for your time and happy hunting.